Hello, everyone, and welcome to the third workshop of the AI Video Hackathon. Today we have Jacob from Story Protocol, who is going to give you guys his workshop.
What's up, everybody? It's Jacob Tucker here from the Story team. I'm a DevRel at Story, and I'm very happy to be joining all of you today. And thanks so much for joining me. What's up, Enzo? Good to see you. Thanks for joining. So in this workshop, I'm going to be showing you how to register IP on Story. And I'm going to be using LivePeer AI in this demo. Actually, before I even started doing this demo or started preparing this workshop, I watched the AI video hackathon from 0 to 1 with LivePeer. This was a workshop that actually happened, it says 6 days ago, done by Encode. So thanks, Adriana and Encode for hosting this one. And also for, Carbon Dallas for making this tutorial from LivePeer. So yeah, if any of you watch this workshop, I'm going to be building off it a little bit just so that you can see how to integrate both Story and LivePeer together in the same application, or more specifically, how to take a image that you generate with LivePeer using the text and image feature and then register that as IP on Story. So before diving into any of the code, what is Story, what is IP, all those questions. Story is a layer 1 blockchain, a purpose-built layer 1 blockchain that is designed to be the IP layer for the world. We want to make registering intellectual property easier for you, to allow you to not only register your IP with license terms on it, which specify how others can use and interact with your IP, but also to allow others to remix your IP, again, all legally on chain using the programmable IP license that I'll dive into in a bit. And also to unlock certain powers like, royalty. So if I have a registered IP on chain, if someone wants to remix that art or remix that image with AI, right, maybe using LivePeer, how can we automate royalty flow on chain? So if you use my IP, you pay me certain amounts of money for that. We also support on-chain disputing. So a lot of just, superpowers around intellectual property we are bringing to the blockchain. So for this workshop, I'm going to be following a tutorial that we have written in our documentation that I actually uploaded a week or so ago. This tutorial is going to show us how to register IP on Story. The only thing that this tutorial is not going to cover is this doesn't actually have the LivePeer integration built in. We actually just use a random image. I'll scroll down to show you. I just use like a random image here. However, for this live demo, I'm going to be using LivePeer AI and registering that image on Story. So let's just get started here. So I have this empty, script here. I have a couple files set up, but it's very straightforward. This is just like an empty TypeScript application here, and I just have one function here, and that's it so far. So what I'm going to do is let's just scroll through this tutorial. And again, if you want to check out this tutorial, you can just head to our docs at docs.story.foundation. And if you scroll on the left side, you'll see under the developer section, you'll see tutorials and then how to add metadata to an IP asset with the SDK. That's the tutorial that I'm going to be following today. So before we even get started, if you have a wallet set up on the Story network, right now this is all on testnet. We're actually calling this version of the testnet Iliad. I have that set up in my MetaMask right here. You can see I have a bunch of test IP. That is our native token. And so this is this is the wallet that I'm going to be using for today's demo. I already see a question here. So from Robert, does Story have its own marketplace, or is it strictly a backend platform for complex IP right management? Also, please put the link to that GitHub repo from 100%. Let me put that in the chat here. This is what I'm going to be using during this workshop. So Story does have its own NFT marketplace right now called Color. I can provide a link to that at the end of this workshop, just because I don't want to, just waste so much time right now searching for it. But we have an NFT marketplace called Color that allows you to buy and sell NFTs on Story, as well as IP assets, which are basically IP on Story. Those are also represented as NFTs. So you can buy and sell those, and the licenses themselves that actually are used to license the IP on chain. Those can also be bought and sold on Color. Again, I will link that at the end of this tutorial. They are also, obviously still in testnet. So not on mainnet yet, but I will link that. Okay, cool. I hope that answers that question. So in order to get set up with our code here, we're just going to follow this little setup phase. So in your ENV file, you're going to want to put your wallet's private key. I'm also going to be using Pinata here, which is basically what I use to upload files to IPFS. So make sure to log in, get an account with Pinata, and get a JSON web token from them. Put that in your .env. And then in addition to that, you're also going to have to provide an RPC provider URL in your .env. We have a bunch of these. If you go on the documentation on the left side here and go to the Story Network Guide, you'll see there's a bunch of RPCs that we support. However, our public default one is just testnet.storyrpc.io. So that's what I'm going to be using for this tutorial. All right. So once you have those three set up in your project, then you're going to want to install the Story Protocol Core SDK, the Pinata SDK, and VM. All right. And so these three things you're going to want to install, as well as LivePeer AI, which is what Carbon Dallas is using in his tutorial here. So you can see, I'll actually increase the font here so you can see it, LivePeer AI right there. Robert says, IPFS is fast enough. I've had a miserable time with IPFS and large assets like images with frequent retries due to broken connects. Yeah, I think for the well, at least for the purposes of this demo, I'm going to use IPFS just because it's really easy. In my experience, it is fast enough, especially if you pay for it. A lot of the free solutions obviously tend to be a bit slower because, well, it is free. However, if you use Pinata and I pay for the service, like my own private endpoint, that actually does work quite well. You're right that especially if you're using AI applications where you're generating large images, which again, AI is not the best at, producing like efficient images. They tend to be pretty heavy just because of how the models are built. However, again, like there are ways of reducing it. There's libraries in JavaScript/TypeScript to help you condense images that I found helpful. I can't remember what the name of one was, but I was using one in my application recently. So there are ways of condensing it. And also, I guess some AI models also allow you to, Sharp. Okay, that's exactly what I knew it started with an S. I was thinking of Sharp. Yes, Sharp is the library that I was using to reduce images. So I generated the image with AI, reduced it with Sharp, and that tended to be really helpful. So yeah, I'm so glad you mentioned that. Thanks, Robert. Okay, so once you have those things set up in your .env, again, you can see the .env.example here. You put your wallet's private key, your Pinata JSON web token, and your RPC. We will cover the NFT contract address in a bit here. But once you have those three set up, then we're going to move on to the rest of the tutorial here. So to get started, and I'm going to copy and paste this. I don't like copy and pasting in tutorials because it's like the whole point of this is for me to walk you through it. But I'm just going to do that because this is just the setup phase. So don't worry, we're going to step back a bit. So I'm going to import a few things here, and I'm just going to make sure you can actually see my code. Okay, you can. Perfect. So I'm going to import a few things here. One is the story client and the story config from the story protocol TypeScript SDK. I'm also going to import HTTP from VM. For those of you that don't know, VM is basically a JavaScript library to interact with the blockchain. You may have heard of, Hard Hat maybe, or there's other, or what is it? Maybe ETH.js, I think, is another one. But VM is what I'm using in my application. VM seems to be the popular option nowadays, but you can use others as well. Truffle, yeah, also I've done that before a few years ago. But VM tends to be the up and coming one. And then VM/accounts, just some types here, address and account, and this function to convert our private key to an account. Also, Robert, yes, I have tried Filecoin as well. They're great too. They host some nice hackathons, and they're a great team. I just find Pinata to be easy for this application. So anyways, what this code is going to do is, this is just some basic VM setup. It's going to take our, and also, by the way, for anyone interested, I'm using Cursor instead of VS Code. Cursor is basically VS Code just empowered by AI. I found it so helpful, and you'll see it like suggesting things throughout this tutorial. It's really nice to use. Yes, Robert, that should be it. I'm not going to click on that link right now, but I believe that's it. Yeah, Cursor is awesome. So I would definitely recommend trying out Cursor. It's super helpful. So this is gonna take our wallet's private key and convert it to an account right here by using the private key to account function. And then we're going to initialize our story config. We're going to pass in our account just to be able to run transactions. The transport here, we're just going to use the RPC URL that we specified in our env file. And then the chain ID is Iliad. Iliad is just the name of our testnet right now. If you were to try this in a few months, this would probably say Odyssey because that's our upcoming testnet release. And then hopefully in the future, mainnet. And then we're going to take our config and we're going to create our client right here. And this client is what we're going to be using to interact with the Story SDK. Okay, so now that we have that set up, we're going to move on to the next step, which is our IP metadata. So before we actually register IP or mint an NFT to register it as IP, and I'll get into all that in a second, we're going to want to actually, get our IP. And in this case, our IP is going to be a LivePeer AI generated image. And so I'm going to go to the tutorial that you may have watched earlier in the week or earlier last week from Carbon Dallas, where he basically provides a very easy to understand example of how to generate an image with LivePeer. I also definitely recommend checking out their documentation, obviously, to explore further, but this is a very easy example to follow. So I'm just going to copy this code into my application here. I'm going to copy that, let's just say right here. I'm also going to copy this code, bring that in, and then I'm going to import LivePeer from their SDK. Again, remember to install at LivePeer/AI. So this is great. Now, this code is basically going to take this prompt and it's going to generate an image with it. Now, I'm just going to quickly take this prompt here and I'm going to put that up here just because we're going to use that in other parts of our code as well. But our prompt is a sentient paintbrush dipped in rainbow ink, transforming floating words into vivid images, swirling text fragments morph into colorful objects, blah, 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 blah. Basically, it's just a test prompt I'm going to use for this video. The model we're going to be using is the Black Forest Labs flux.1/dev. That's just one of the models that they're using. And then this result should give us a image that we can view. So just to test things out, because why not? Let's just console.log, or actually, I believe in here, let's just do it what he did, where let's just console.log the image. And so we're not going to be using the client or anything story related yet. This is just using LivePeer. Let's just run this. So if I run npm run metadata, this is just the script I have set up to run the metadata script here. Let's run this and see if we can actually get it working. So let me just increase the font here so you can see this as well. And hopefully if LivePeer works correctly and if the demo gods are with us, we should see that this logs out a image that is generated using our prompt. So let's all cross our fingers and hope it's with us. Robert said, what part of the blockchain operations does Cursor take care of while interactions blockchain? So Cursor is basically it's basically just AI VS Code where it just gives you suggestions on code as you're typing. So it's really helpful. Oh, here we go. So here's the response from LivePeer. We see the URL, the seed, and it's NSFW false. So these are the attributes it returns. And if we actually go to this link, let's check it out. Okay, cool. This is the image that it generated. So definitely rainbow related, very artistic. Clearly like it looks like it's paint. So it looks like the prompt worked and LivePeer is doing its job, which is great news for our tutorial, obviously. So that's awesome. Okay, so now that we have our result here, now we're going to actually dive into the rest of the tutorial here and set our IP metadata. So let's just do that together. So I'm going to go back to my Cursor application. I'm going to remove this for now and continue. So I'm going to say const IP metadata. And again, the whole point of this next part of the tutorial is to create the IP metadata surrounding our piece of IP, which is that image. And so this way, when we register the IP, it correctly displays on the Story Explorer and in the rest of the Story ecosystem so that other apps, for example, like Color Marketplace, can correctly understand what this IP is and some of the details around it. So we're going to say const IP metadata equals client.IP asset, .IP asset .generate IP metadata. Okay. And so now we're going to pass in a few attributes here. And also, by the way, just Robert, in case you're curious, you can see it's like making suggestions here. So that's what I really like about Cursor. But the title, we will just say is a LivePeer AI image. The description, and look, see, like it even suggests this, so I can just press tab here and it just auto-generates. This is a test image generated by LivePeer AI. But for this purposes, for the description, I'm just going to put the prompt. So that the prompt up here that we have, I'm going to use that as our description. And then I'm going to put some attributes here. One of them I'm going to say, well, let's just say, I don't know, a cool attribute might be, let's think about it. Oh, we could pass in a key that says NSFW, because remember, that's one of the properties that LivePeer returns. And we can say, you know what, the value is going to be, let's say result.image response, image response. Image response dot images. Images here. Oh, I don't know why it's doing that. Images at 0 dot NSFW. If it's true, then we'll return true as a string. If it's false, then we'll return false. So that's one attribute we can return. Another one we can say is like, let's just say key, AI generated. Is this piece of IP AI generated? We'll say yes, it is true because obviously this is AI generated. So I see a question from Robert here. Pardon the complex question. No worries, Robert. Does Story Protocol support royalty hierarchies? For example, suppose some artists make a, I see Mohammed has similar questions. That's great. For example, suppose some artists make a bunch of 3D models, each one a Story Protocol managed asset. Now an artist builds an NFT that uses a bunch of 3D models. When the artist sells his NFT that uses the other art, okay, wait, sorry, the chat's like going up and down, it's hard to read. Now an artist builds an NFT that uses a bunch of those 3D models. When the artist sells an NFT that uses the Story Protocols, right, intelligently distribute the owed. That's a fantastic question. So actually that exact use case is supported by Story and something we've thought a lot through. We have certain applications that are actually registering their AI models and the data sets that are used to generate the AI models as IP assets. Let me actually go to our docs really quickly. We have this one module called the grouping module. This was released in our latest testnet release because of this use case, where people wanted to basically register entire AI data sets that are used to train AI models as a IP asset group. An IP asset, I was going to get into that in a bit, but an IP asset is basically a piece of IP on Story that is a registered NFT. So you take an NFT, you register it, it becomes an IP asset, and that's essentially a piece of IP on Story that has license terms associated with it. Like, let's say non-commercial social remixing license terms, where if you want to, remix my IP or create derivatives of it or use it in a non-commercial sense, you can do that, but you can't commercialize my IP. Like that's essentially what the license terms are. So a grouping module allows you to register a group of data as an IP asset or as a group IP asset. And then anytime someone wants to maybe generate their own AI model, they can use that data and create and make their AI model a derivative of that data. And so anytime someone trains on that model or anytime someone pays that model, it would automatically give revenue to the original data set. Similar to what you described is, let's say someone generates an image from an AI data set. Yes, they would register their art as a derivative work of that AI data set or that AI model, and royalty would automatically flow to the associated pieces of IP. Mohammed says, could you please elaborate on how Story Protocol handles ownership split between multiple users, especially in cascading models? For example, when user 2 remixes asset created by user 1, any royalties generated by leasing/sale of asset 2 need to be split between user 1 and 2. How are the dependents handled? So I can definitely dive into this later after the workshop is over, but I think what you're asking is like, how does Story handle, revenue split between multiple owners? The very simple explanation is, if I have a piece of art that's, let's say, asset 1, and then someone creates a remix of that art and that's asset 2, and they want to commercialize asset 2, let's say it's some piece of merch, or like someone wants to take my drawing and put it on their merch and sell it, they can do that. But any percentage of revenue, like let's say the person who owns asset 1 specifies that derivative works or that commercialize their work have to share 5% of the revenue. My merch would have to share 5% of the revenue with asset 1 or the person who owns asset 1, and that would be enforced legally by our on-chain license. I hope that answered that question, and more complex examples that I'm very happy to get into after the fact. And really quickly, Robert, so Story Protocol does so Story Protocol right now supports one license type, which is called the programmable IP license, or what we're calling it is the PIL. This is a custom license that we have generated with our legal team. You can actually view the full legal text if you go to the PIL license on the left here, and you click on this button right here, this here link. You can actually see the legal text. In fact, I can actually pull it up right now. This is literally the legal text that we have written that is enforced on chain through our protocol. But we do also support multiple. So this is one license template, we call it. The protocol does support a number of different license templates. I believe right now, because we're in testnet, it would have to be approved by our protocol directly. So we're expecting most people to use the pill as the default license template, but you should be able to use different ones. But again, I'll dive into that more later. So I'm going to take a brief break from the questions here and go back to the tutorial. But Robert and Mohammed, I'm loving the question you guys are asking. Thanks so much for participating so far. But I'm just going to dive back into this for a second here. Okay, what step were we on? So before we register our NFT and make it, or before we mint an NFT and register it as an IP asset, which is coming soon, we have to specify certain metadata on our IP asset. So I believe that's where we were. So I made a little title. The description was the prompt we used. And then we specify some attributes, like is it NSFW? Well, we can actually use one of the responses, the response value here to determine that from LivePeer. And then also, it says AI generated, true. Obviously, it's AI generated, so that's great. And the IP metadata that we're expecting there actually is a template for this. If we go to the IP metadata standard, I'll put this link in the chat here. This is the standard that we're expecting. So you can see there's a title, description, IP type, relationships, watermark image, media, blah, blah, blah. There's a lot of different stuff here. Each of these types is specified in our documentation. But there's a lot of stuff here, right? And you can see, well, we've only specified 3 of the attributes, but we can use the generate IP metadata function to automatically generate all the types. And just for ones that we don't provide, it'll just specify the default options. So that's a helper function we can use to generate this IP metadata. But again, to see the actual standard, you should go to the link I just provided in the chat, this link right here. Okay, great. So that is our IP metadata. Now, the next portion is the NFT metadata. So we support both metadata on the NFT and metadata on the IP. Now, to be honest, the metadata on the IP is definitely the most important part. The reason that we support NFT metadata is, for example, what if the NFT itself is the IP? So if you think of a Bored Ape, or if you think of an Azuki, or if you think of a Pudgy Penguin, these are all popular NFTs. All of those NFTs are, IP themselves, right? What if I wanted to use an Azuki on my t-shirt, or if I wanted to put a Pudgy Penguin into a little plushie toy, right? So sometimes NFTs can be, IP themselves. So that's why we also support NFT metadata, because those NFTs, have metadata already. And this follows the ERC 721 metadata standard that's been out there for years now, just to make it simple. So that's the standard that we support right now. So let's go back to our code here. And so you can see for NFT metadata, it's very simple. It's literally just a name, description, image. Again, for this demo, I'm just going to copy and paste this just because it's very simple. The name, we can just say, again, LivePeer AI image. The description will make the prompt, and the image will make the image here. We're going to make the image from the response. Okay, so the image from the LivePeer response we will make as the NFT image. Now you'll see later. I won't. We'll come back to this in a couple minutes or whatever when we're done. But you'll see that the image that shows on our Explorer when you register the IP is the NFT's image. So if a lot of the metadata that our Explorer is reading will come from this metadata that we set right here. Okay, so that's that. Awesome. Okay, so let's now go to the part where we actually want to. Actually, before we get to that part, let me dive back into questions here for a second. So Robert says, does Story Protocol warn derivative asset makers about the combined downstream royalty percentages? For example, warning your derivative NFT will have to pay a 9% aggregate royalty given your source NFT assets. That's a really good question. I mean, in terms of like the code itself, no, there is no warning, although I really like that idea. That makes me think like there should be a better way to say, okay, you know what, if I register my asset as a derivative, this is exactly what's going to be paid. There is, in our protocol does support, reading that kind of data, like, what is the license terms of this asset. So there are ways of knowing that. And of course, like we do have documentation on the royalty module. We support 2 different types of, royalties. One is liquid absolute percentage. One is liquid relative percentage. Absolute percentage is basically saying, okay, I'm a parent, and any IP, whether it's a direct derivative or like a grandchild, any derivative owes me 5%. So if I have a child and a grandchild, both of those owe me 5% of their revenue. Relative percentage says, okay, you know what? I want 5% like relatively. So, I want 2% of my child, and then that child can say, I want 5% of my child. And so the grandchild will pay 5%, which will then, and then that child will pay 2%. You can kind of see how it's a little bit different. So we do support both these types. I really like your idea that we should support an easy way to view that. So that, for example, if there's a website where someone's registering their derivative or their IP as a derivative of another, there should be a modal that says like, okay, you know what? You're going to pay in total 12% of your total revenue out to other people. So that's a fantastic idea, and I'm sure our team, has thought about that and is working on that. But I will follow up with them after this because that's a great idea. All right, and that's awesome, Robert. I'm really glad to hear that this is seeming helpful so far. So thanks a lot for that awesome comment. Okay, let's go back. Trying to switch context back to here. Okay, so before we dive into the other part, so we're gonna upload this metadata to IPFS. So in order to upload to IPFS, I have a function here, or a file here called upload to IPFS. Now this is not story or LivePeer related. This is just simply Pinata using the Pinata SDK. So I'm going to say const Pinata SDK equals require, and I'm going to use at Pinata/SDK. And then look at cursor, by the way. It's the auto suggesting stuff. I love that. So I'm going to export an async function here called upload JSON to IPFS. It's going to take in JSON metadata, and it's going to return a promise of a string. All right. And then inside here, we're going to say const Pinata equals new. We're going to initialize a new client on the Pinata SDK using the Pinata JWT that we set in our env file. Then we're going to actually upload that JSON to IPFS. I'm going to say const IPFS hash equals await Pinata dot pin JSON to IPFS, and we're going to pass in the JSON metadata that we've put there, and then we're going to simply return that IPFS hash back to us in the other file. Okay, so just very simply, and you can always check out the Pinata docs, but this is just uploading a JSON to IPFS. Again, made very easy by Pinata, so thanks, Pinata. You could also use Filecoin like Robert suggested. Yeah. Awesome. So now that we have that written, let's go back to our main file here, and we're going to upload this to IPFS. So, or both of these objects to IPFS. So let's say const IP IPFS hash equals await upload JSON to IPFS, and we're going to pass in our IP metadata. Now we obviously need to import this into our file. Let's just go ahead and import this IPFS. I don't know why it's doing that. Upload. Cool. I guess cursor is a bit buggy too. Okay, so there we go. And now next we're going to upload the NFT one. So again, cursor, nice suggestion. Const NFT IPFS hash equals await, and we're going to upload the NFT metadata as well. So that is great. All right, so now that we have uploaded both of these things to IPFS, now we're going to do our final step here, which is actually minting an NFT and then registering that NFT as an IP asset. You may be wondering, why do we have to mint an NFT? Why can't we just register this data as an IP? The answer is because our protocol just requires that in order for you to register IP on our blockchain, that you mint an NFT that represents it first, and then register that NFT as an IP asset. The reason for that is because whoever owns the NFT owns the IP asset. So this is actually very convenient, because let's say I register a piece of IP. Let's say it's a character that I created. Let's say it's Harry Potter. And I register that I'm J.K. Rowling, and I register my Harry Potter character as IP. If I go ahead and make a crap ton of money with that, right, I can then sell that NFT that was registered on Color Marketplace, for example, or I could sell that NFT, and then whoever owns that NFT now has complete control over that IP asset and can earn the revenue from it, earn the royalties from it, all that kind of stuff. So the NFT allows you to basically control who has ownership over that NFT or over that IP asset, or that IP, and manage it that way, which is pretty cool. What chains are supported for mint NFTs? So right now, we support NFTs. We're still in testnet. Supports NFTs that are directly on Story. However, we want to make some sort of cross-chain API to support other EVM-based blockchains, so that if you have a Azuki or Pudgy Penguin or Bored Ape or whatever, you could register that as well. Yeah. Okay, so now to go to the next part of the tutorial, we've done this. Now we're going to register the NFT as an IP asset. Now there's two pathways here. The first one is, what if you already have an NFT minted? So if you already have an NFT, let's say it's a Pudgy Penguin or a Zuki that's on Story, right? Or you simply just have your own custom NFT contract, you can follow step 5A of this tutorial, which basically just uses the register function in our SDK, where you pass in the NFT contract address of where your NFT is minted, the token ID of that already minted NFT, and then all the metadata that we just created. Or if you don't have an NFT yet and you want a convenience function that combines both minting and registering in the same transaction, then you would go on to step 5B. And so for this tutorial, because 5A is relatively straightforward, so if you wanted to do this pathway, you could just copy and paste this code. I'm going to cover 5B because it's the more complicated scenario, but it actually ends up being the more convenient method, and 90% of the time, the best method to use for registering IP. So for this part of the tutorial, in order to use a function that both mints and registers an NFT in the same transaction, we have a utility contract called the Story Protocol Gateway, or SVG for short, that combines multiple interactions into one. So for example, if we want a transaction that mints an NFT, registers it as IP, attaches license terms to that IP so that others can remix it, those are three operations that we're going to combine into one transaction so that it's a convenient way to register your IP. And again, this is using the SPG, which is a utility/periphery contract that we've used to make your life easier. And so if you want, if you want further documentation on the SPG, you can go to the SPG here in our docs and read a bunch about it. I'm proud of these docs. I think it's pretty well done. So if you want more explanation on that, you can definitely go there. Robert says, some repo you're demoing have code for the MetaMask interaction, so we don't have to suss that out. Yes, so I think what you're asking is, well, this tutorial is like Node.js. So this is actually just using a private key, so it could be any wallet. Specifically with MetaMask, we also have a React tutorial where a user is interacting with their wallet so they can register an IP with their wallet. If you want to check that out, go to sandbox.story.foundation. This is actually a website that I created to help React developers better interact with MetaMask. You can go there. And this actually, if you click the GitHub link in the top right, you can actually be taken to an open source example of using the React SDK, so that again, users can interact with their wallet. So even if I go ahead and log in here, you can see there's MetaMask supported here. Yeah, so you're totally welcome, Robert. Thanks for asking. Okay, so what we're going to do next is, in order to register IP, we're going to use this function, which is mint and register IP asset with pill terms. So again, this does three things: mint an NFT, register it, and then attach license terms to that IP so others can remix it. But there's a caveat here. In order to use this function, we need to deploy what's called a SVG NFT contract. And that's just so that the SVG utility contract can do all these things for us, okay? And the good news is, even though this is an annoying prerequisite, we only have to do this one time, and then we can mint and register an infinite number of NFTs after that, or I guess technically infinite. Okay. So in order to do that, I have another script here called create SVG collection, and this is how we're going to create our own SVG NFT collection. Now here again, there's two ways to do this. Either A, you can create your own SVG NFT contract. And if you want to do that, you just have to deploy an NFT contract that implements the SVG NFT interface. So if you want to, for whatever reason, I wouldn't really recommend doing this, but because it's harder. But if you want to, you can make your own SVG NFT contract that that implements SVG NFT, or you can just use our SDK to deploy an SVG NFT contract for you. So it's made a lot simpler. Taya, I believe that's how I say it. Thanks so much for joining us. And this will only be like maybe 10 more minutes, but I hope the recording is made available to you. Thanks so much for coming, Taya. Okay. So let's go ahead and do that now. So in order to do that, I have another script set up here. All of this is familiar to you. We've already covered all of this. The only part we haven't covered is actually calling that function here. So let's just say const new collection equals await client.nft client.create NFT collection. And in here, we're going to pass a few things. One is name, which let's just say test NFT. Symbol, we'll just say test. Again, this is deploying a NFT contract so that the SVG can use it. And then that's great. And so now that we've done that, what we're going to do is just uncomment this console log here. And this will give us the NFT contract address of that newly deployed collection. So again, I have in my package JSON a script to run this code. So if I just say npm run create SVG collection, it should do this quickly for us. Oh, please put the link to that exact SVG. So I believe what you're asking for is this. This is in our documentation in the tutorial. I'll also put it in the chat here. Again, this is a interface that you can implement to make your own SVG NFT contract. But again, I wouldn't really recommend doing that because it's made much simpler by just calling the function directly from the SVG anyway. But there it is. Okay, great. So in our terminal, we should see here's our NFT contract address. So you take this address, and I'm going to modify my env really quickly. So I'm just going to paste that into my env. Great. And so now that I've done that, I'm going to come back here and I'm all set up. Okay. So again, you take your NFT contract address, you're going to put that into your env where it says NFT contract address, and you only have to do that one time. So that's just the prerequisite. So now that we've done that, we can finish this tutorial by going back to our main file and minting and registering and attaching terms to our IPFS. We're going to say const response equals await client.ipasset.mint and register IP asset with pill terms. Mint and register IP asset with pill terms. Perfect. And then we're going to put some stuff in here. So the first thing we're going to say is the NFT contract. This is just process.env.nft contract address, what we just supplied. And we're going to say as address. Robert says, okay, got it. You don't have to create the contract yourself, but you do have to get the hash for the one created for you by the function and copy it. Exactly. So again, this function, the mint and register IP asset with pill terms, requires there to be a deployed SVG NFT contract. And so that is all handled for you by our SDK if you just call this function. And if you go to the tutorial, there will be a link to this completed code so you can see this. And the result of this function will give you the NFT contract address that you need in order to call this function here. Exactly, yeah. Great. So now that we have added our NFT contract here, that is awesome. And the next step is we're going to add our IP metadata. So the good news is we've handled most of this already. So there's an IP metadata object. And in here, we need four things. The first one is the IP metadata URI. This is the IPFS link. So I'm just going to use a basic IPFS gateway, which is just a public one, which is ipfs.io/IPFS. And then we're going to put in our IPFS hash that we got when we uploaded our IP metadata to IPFS. So I'm just going to enter that there, which is great. And then the next one is the NFT metadata URI, which is, again, just the NFT IPFS hash that we got by uploading our NFT metadata to IPFS earlier. Now, we need two more things. The first, or the third one, I should say, is the IP metadata hash. Now, this is used basically as like a verification mechanism for the protocol, just so that if someone changes the metadata later on, you'll be able to verify against it. And in order to get this, we got to add a couple things up here. All we're going to do is hash the object that we're just going to hash our metadata object. So whatever object is returned from this, which is basically title, description, attribute, and all the other default attributes from our IP metadata, we're just going to hash that object. We're going to do it using the crypto library. So we're just going to say const IP hash equals create hash, which is just from the crypto library. So create hash. Oops. Let's get rid of that here. And I'm going to import that actually up top. I'm going to say import create hash from crypto. Crypto is a default library available in Node.js, so it's there's no extra dependencies needed here, which is good. But again, this looks complicated. Create hash. SHA-56, blah, blah, blah. Looks complicated. All it's doing is just hashing the object so that we can pass it into our protocol here. And then we're going to do the same thing for NFT hash. So we're going to take the NFT object here and hash that as well. And so that is going to be our variable right here. And we're going to pass those in down below. So we're going to say OX, pass in our IP hash, and then we're going to pass that in for our NFT metadata hash as well, OX NFT hash. Awesome. So now we have handled our IP metadata. So the last thing we're going to pass in here is the PIL type. Now remember, PIL type is coming from the PIL, which is the programmable IP license. This is our real legal on-chain license that we use to license IP. And so there's a couple different options that we have here. We're going to import PIL type from our SDK. Let's go ahead and import PIL type. And this will give us a couple options. We can either use commercial remix, commercial use, or non-commercial remix. These are just different license terms we can use for our IP and determine how others can use it. If you want more details on this, you can go to the programmable IP license tab on the left here and click on PIL flavors. This will give you a bunch of different, what we call flavors, which are just different license terms. So non-commercial social remixing says others can remix this work. They can distribute their remix anywhere. They have to credit you, but they can't commercialize it. Whereas if you go to commercial use says, okay, they can do all those things, but they can also commercialize that work. They just have to give you an upfront minting fee. So they have to pay you, for example, 10 IP or 10 USDC in order to use your work. And then commercial remix says, okay, they can pay you a minting fee, but they also have to pay you a percentage of revenue that they earn in the future. So if every time you sell your merch, for example, which is a derivative of your IP, they have to pay you 5% royalties or something like that. So there's a couple of different flavors here, or you can also create your totally own flavor by specifying your own terms. Again, these flavors are just combinations of these terms here that we think are popular examples, which is why we call them flavors. Am I looking at the same repo? So that repo is the periphery repo. By same, I'm not sure what you're relating that or what you're trying to compare that to. I'll wait for a response for you on that. Oh, the code on your screen. No, so this is coming from this tutorial here, and there's a completed code example here, which I will link in the chat. So everything I'm doing here, remember, this does not include the LivePeer stuff, but you can include the LivePeer here. But all I'm doing is copying this code right here, and you'll see it's pretty much identical. Hadrian says, our royalties, Solidity, smart contract, how do you enforce it? Great question, Hadrian. So if the revenue is on chain, so for example, if someone were to send you like 100 USDC to the derivative IP, then yes, that is automated directly by the protocol because we can do that. If it's off-chain payment, it's not automated because you can't really automate that, but it is enforced by the license. So in the same way that right now, if I were to strike a deal and say, okay, if I want to use Obi-Wan Kenobi, which is a Star Wars character, on my t-shirt, I have to pay you a certain amount of revenue. The same way that's enforced right now in the current legal world, that is still enforced on Story because we have a real legal license that is enforcing that. So it's not automated, but it's enforced still. And you can bring someone to court. Again, this is all in testnet. So, the disclaimer here is this is, theoretical thus far because there isn't a mainnet true example of this, but you would enforce that legally, and you could, go through traditional legal arbitration where you were to bring someone to court if they violated that license. So I hope that helps answer that question. Okay, great. So going back to this example here, we're going to specify the people who had to code this up for you, but then again, better than me. Yeah, we have a really good engineering staff. I will say that. So for this example, I'm going to choose non-commercial remix just because that's the default one. Actually specifying this here, although we have to specify it for there to no longer be errors, this actually is a bit silly because every single IP on Story automatically has non-commercial remixing terms on it by default. So by specifying this, we're just saying, you know what, we're okay with keeping it as non-commercial. So we'll just keep that there for now. And then the only other thing we're going to provide here is transaction options. This is just options on this call. And we're just going to say wait for transaction true. That way, because we specified this, we're going to get some data back from this transaction. So that's great. And then we're just going to copy a console log. We're going to copy these two console logs here just so that we can read some data from this. So just to review, before we actually go through with this, let's review what we've done. So we've set up our story config for the SDK. We've generated a text to image using LivePeer AI. We've generated IP metadata. We've created NFT metadata. We've properly configured this for our call. And then we've actually made the final mint and register IP asset with pull terms, which will mint an NFT, register that NFT as IP asset, and then add these terms to it, even though they're on it by default, and then log some basic info here. So if the demo gods are with us today, this should work. And we, oh, okay, great. So that doesn't work. That's awesome. Oh, okay. I believe it's a TypeScript error. I think I have to specify any here. So hopefully, crossing my fingers again, please, that this will work. I believe it will. I have some faith here. Also, Robert and Mohammed and anyone else, if I accidentally missed a question, please don't hesitate to copy and paste it so I can answer it. I know I might have skipped over some, but I tried to answer all of them. Robert said, hopefully you will post a LivePeer enhanced sample code at some point, perhaps in a LivePeer. You know what, Robert? That's a great suggestion. I was thinking, because I manage all the documentation, I was thinking of maybe adding like a subsection here of like using story with other applications. So I could add like a LivePeer tutorial here. Definitely, I will do that, Robert. Thanks, and thanks, Mohammed. That's really sweet of you. All right, so it looks like it's worked here. So we got a console log that said the root IPA was created at this transaction hash. The IPA ID, which is basically the ID that's assigned to each IP asset, that is here. And then we also have this URL, which links right to our Explorer, so we can view that on the Explorer. So usually it takes a couple seconds to load, but boom, there it is right there. So this is, again, which is, I think, really cool, officially registered IP on Story, this image, right? So here it is, LivePeer AI image. Here's our image. You can see the IP details. So you can see the IP ID, the title. Here's the prompt that we provided as the description. And then you can also see the IP metadata URI. So if we click on view metadata here, you should see all the metadata that was provided. Again, you may be wondering, what is all this? Because we only provided, if you see here, we only provided the title, description, and attributes, which you can see here, right? If you look at attributes, you can see key, NSFW is false, AI generated is true. But there's a bunch of other stuff here. There's tags, there is media, there's creators. This is all coming from, remember, the IPA metadata standard. We just didn't specify them, so it just sent the defaults for them using this generate IP metadata function. All right, but if we go back to our Explorer, boom, we see, here's the license that's attached. So here's the non-commercial social remixing license here. And we can also see the NFT details. So here's, again, the NFT name, the description, the token contract it was minted from, the token ID is number 1, the creator, what chain it's on, the owner, and then view metadata. So this is the NFTs metadata, which we provided right here. Boom. All right. So we could continue with this, although I don't want to take up too much time, and I'm already approaching an hour. But if we were to continue with this, and if you were to dive more into story, let's say you wanted to remix this image. So actually, if we go back to LivePeer AI, what if you wanted to use the image to image feature, where you input an image and output a remixed version? That's a perfect example where you could register that remixed image as a derivative of this image. And so that would show up under lineage here, where you could see the child IP asset appearing underneath the parent. And then any royalty flow between the child and the parent would be enforced, or would show up right here under royalties. Now, again, because this currently has a non-commercial social remixing license, there would be no revenue sharing, right? Because there's no specified commercial usage. But if we were to put a different license on here that said, you know what, commercial remix, you have to share 5% of your revenue, that would come up under royalties right here. And one thing that Story also does support is tipping. So you can just like tip a piece of IP. And that would Story Protocol would automatically handle the flow of that revenue upstream to all the parents. But I'm just trying to give you an exciting vision for what Story can do. So that is the demo. I want to go back to what Robert said earlier with Color Marketplace. I want to see if I can scroll to that. I believe it's colormp.com. Yes. So this, Robert, you were correct. This is the NFT Marketplace. This is Color. You can see people selling different, IP assets on here, but they're also, I believe, selling licenses. So you can sell licenses too. So let's say I mint a private license to you that says, you know what, only you can commercialize my IP. So that person can take that license and, create a DeFi application out of that. So they can sell and buy that license, which is also really cool. The license itself, we're calling it a license token. That is also a NFT that can be bought and sold. So lots of different DeFi use cases that arise in Story. And you're exactly right, Robert. Yeah, private license control. Yes, the ability to mint private, unique license terms to certain people, and then they have control over that. Yeah. So anyways, that's the demo, everyone. Thanks so much for tuning in. Any questions? I mean, I know everyone's been asking questions throughout. Just very support written in I've actually never heard of that, Robert. COBOL, COBL, COBOL. Oh no, I don't think so. No. It's only Solidity right now. Only Solidity right now. Yeah. Yeah, I've never heard of that, but that's funny. I wouldn't know. Thanks, Enzo. Yeah, thanks everyone for coming. I believe that's it. So I'll stick around for some questions, but yeah, I'm too young for COBOL, unfortunately.
Amazing. Thank you so much, Jacob. That was such a cool workshop. And thank you guys also for being so active in the chat and asking lots of questions. It really does make a difference. So if there aren't any more direct questions, the video, like the workshop was recorded, it will be edited and uploaded by tomorrow. And I'll send it to you guys on the Discord channel that we have.
I linked in the chat. One is the Story Discord. So if anyone has any questions, you can always come to the Discord and ask questions in the dev channel. We have like a forum for questions. I'll answer any questions there. Or you can also DM me on Twitter. I also post a lot of Story updates on Twitter, obviously. So check that out too.
Thank you, Jacob. That was fantastic. And thank you everyone for participating. And we will see you all tomorrow for the 4th workshop of the AI Video Hackathon.